let's consider the equation sine theta equals 0.61. We want to find all possible solutions of this equation. Well, if we draw a unit circle, we can model this equation very easily. 0.61 is going to be the y-coordinate of a point on the unit circle whose sine, or if the point is located in angle theta, such that the sine of theta equals 0.61. So if we go from 0.61 straight across, we see that there's an angle theta here whose sine appears to be 0.61. If we take the inverse sine of 0.61, we find that that angle is 37.6 degrees. However, that's not the only angle whose sine is 37.6 degrees. If we move over to here, we see that there's another point where the y-coordinate is 0.61, so that the sine of this angle over here, whatever this angle might be, will also be 0.61. Now, by the symmetry of the situation, by the fact that this line is horizontal and therefore perpendicular to the x-axis and the circle is symmetric about the origin, we can determine that this angle has to be 37.6 degrees from the negative x-axis, just like this one is 37.6 degrees from the positive x-axis. And that's going to tell us that this angle is 180 degrees. That is, we think of starting here, moving around to 180, then back 37.6 degrees. So this is 180 degrees minus 37.6 degrees, and that comes out 142.4 degrees. And that's another value of the sine of theta, such that sine theta equals 6.61. You might think that we're done at this point, but we're not. We can move all the way around the circle, all the way through 360 degrees, and then another 37.6. That's a total of 397.6 degrees. If we move 397.6 degrees from the positive x-axis, we go all the way around here, and we get to this point again. And so we have another angle whose sine is 0.61. If we go all the way around to 100 or 360, and then another 180, which is 540, and then back 37.6 degrees, we end up at another angle whose sine is 0.61, and there's no end to this process. So we can summarize some of those calculations. Okay, we have theta equals 37.6 degrees, our inverse sine of 0.61. We have theta is 180 degrees minus 37.6, 142.4. We can go around 360 and another 37.6, that is one complete cycle, plus our 37.6 degrees, and get this angle. We can go around 360 and another half cycle, which brings us to 540, and then backtrack 37.6 degrees, giving us 502.4 degrees. We can go two complete cycles, 720 degrees, and add the 37.6. Two complete cycles and another half cycle up to 900, and then back 37.6, obtaining these angles. And, of course, there's no end to this, so what we're going to say is that we can go any whole number of times around the circle, n times 360 degrees, which brings us back to our original positive x-axis, and then we can add 37.6 degrees to that to get our first quadrant angle. Or we can go n times around the circle and another half time, which gets us around to the negative x-axis, and then backtrack 37.6 degrees. So these are our formulas for the angles at which the sine of theta equals 0.61. Well, that's not all. Let's solve the equation sine of 3x minus 2 equals 0.61. Well, if the sine of something equals 0.61, then the something, which in this case is 3x minus 2, could equal 37.6 degrees. If 3x minus 2 is 37.6 degrees, then it's certainly true that the sine of 3x minus 2 is 0.61. And of course, if 3x minus 2 is 37.6 degrees, we can solve for x easily and determine that x is 13.2 degrees. Alternatively, 3x minus 2 could be 142.4 degrees. The sine of 142.4 degrees is 0.61. And that, solving for x, would tell us that x could be 47.47 degrees. Or 3x minus 2 could be 397.6 degrees, etc., etc. In general, 3x minus 2 could then be n times 360 degrees plus 37.6 degrees. We can solve that. We add 2 to both sides. We get 39.6 degrees. We divide by 3. We get n times 360 plus 39.6 degrees over 3. And dividing the 3 into 360 gives us 120, and the 3 will go into 39.6, 13.2 times. So we see that x is n times 120 degrees plus 13.2 degrees. Or the other possibility, we could have n times around plus half a time around and then backtrack 37.6. That's what this formula stands for. And we can solve that for x and just proceed in the obvious fashion. And I think we end up with n plus 1/2 times 120 degrees minus 11.7 degrees.